There's a sticker available on Amazon for $15. A $15 sticker sitting on a shelf right now. It reflects up to 80% of incoming solar heat before it ever becomes warmth inside your home. It reduces solar heat gain through your windows by up to 80%. NASA engineers developed and tested this film in the 1970s. The energy industry has been aware of this for 5 decades. In 1972, a NASA team at Johnson Space Center was wrestling with a problem that had nothing to do with rockets. The problem was heat. Specifically, heat pouring through the windows of their research buildings in Houston. Houston's summer temperatures regularly hit 105 degrees Fahrenheit, and the industrial air conditioning units in those facilities could not keep pace with the thermal load coming through the glass. A physicist on the team had spent years studying metallic thin film coatings for spacecraft. In orbit, spacecraft need to reject enormous amounts of solar radiation to keep instruments and crew alive. The coatings he worked with could reflect the majority of that radiation away before it could be absorbed into the structure. He asked a straightforward question. What if that same reflective film was placed on the windows of a building here on Earth? The experiment was run. The results were documented and published in NASA Technical Report number TND 7492. A metallic window film reflected up to 78% of incoming solar radiation before that radiation converted into heat inside the building. The air conditioning load dropped immediately and dramatically. No moving parts, no power required, no recurring maintenance of any kind, just a film placed on glass that intercepted solar radiation at the point of entry. Federal facilities, managers read that report and responded. Government buildings began adopting the technology quietly and systematically. By the early 1980s, solar control window film was standard specification for all federal building upgrades right across the United States. The General Services Administration, which oversees all federal government buildings in this country, has required solar control film as standard material in its building programs for more than 30 consecutive years. For the residential housing market, for the homes where families live and where the majority of summer cooling bills are generated, almost nothing happened. Almost nothing at all for more than 50 consecutive years. Part 2, the physics. They decided you did not need to know. Here is what actually happens when sunlight reaches a glass window. Not the simplified version, the complete version. When solar radiation strikes a pane of glass, 3 distinct events occur simultaneously at the molecular level. A small fraction, roughly 8%, reflects off the outer surface of the glass immediately. This is the visible glare you see when sunlight hits a window at an angle. That fraction is gone. It never enters. A second fraction, between 5% and 10%, depending on the glass composition, is absorbed directly into the glass material itself. The glass heats up. That stored heat then radiates inward into the room from the warm glass surface even after direct sun has passed. The remaining fraction, the majority of it, passes through the glass as solar radiation. That radiation travels across the room and strikes your furniture, your floors, your walls, and your ceiling. On contact with any interior surface, it converts entirely into infrared heat. This is the residential greenhouse effect occurring in every unprotected room of your home every afternoon of every summer. The U.S. Department of Energy measured this precisely. In a hot climate, up to 40% of the total heat load inside a home enters directly through the windows, not through the roof, not through under-insulated walls, not through gaps in the building envelope, through the glass. The Lawrence Berkeley National Laboratory took that measurement further. Unshaded south-facing glass under direct afternoon sun transfers up to 250 BTUs of heat per square foot per hour continuously into the interior of the living space. To make that number concrete, that figure equals a 1,000 watt electric heater running at full output, placed directly behind every unprotected window every afternoon for the entire duration of the summer season. You are not running your air conditioner against the outdoor temperature. You are running it against your own windows. Part 3. What glass actually costs you, quantified. The average American household spends approximately $1,200 to $200 annually on electricity across all usage categories. Temperature control accounts for 44% of that total. In Florida, Texas, Arizona, and across the American South, the cooling fraction is substantially higher. A home with 4 unprotected west-facing windows generates between $60 and $90 of unnecessary additional monthly cost during summer months. That is, heat entering through glass that was never supposed to enter. Across a full year, that is between $700 and over $1,000 paid entirely to compensate for unprotected glass. Now consider that the average American homeowner lives in their home for 13 years. Over that period, unprotected west and south-facing windows in a warm climate can conservatively cost between $9,000 and $13,000 in excess electricity. Electricity that would not be required if the glass had been treated with a film that costs $15 per window. That is not an estimate based on best-case conditions. That is the documented mid-range from Department of Energy modeling for warm climate residential housing. It is published. It is accessible. It was never sent to you. While residential homeowners remained unaware, the commercial real estate sector moved quickly. Skyscrapers in every major American city adopted solar control window film within years of the NASA report becoming available. The economic incentive was direct and immediate. A large commercial building with extensive glass facades can spend millions of dollars annually on cooling. A one-time film application with a useful life of 10 years represented immediate and measurable savings at a scale that made it impossible to ignore. The Empire State Building completed a comprehensive window upgrade that included solar control film as part of a major energy renovation. Their documented result was a 68% reduction in solar heat gain across the entire treated building facade. The project recovered its full installation cost within 1 year of completion. The Chrysler Building followed. The Willis Tower in Chicago, dozens of federal courthouses, university campuses, hospital complexes, and municipal office buildings across the country made solar control film standard practice. The data from those applications fed into the Department of Energy's own modeling. The DOE formally classifies solar control window film as one of the highest value efficiency upgrades available for buildings in warm and hot climate zones. That classification exists in published documentation today. It has existed for decades. The residential homeowner received none of this information through any channel that reached them directly. Part 5. The business model that explains the silence. The residential energy efficiency sector generates over $60 billion per year in revenue in the United States. That market includes HVAC system replacements, service contracts for annual maintenance, attic insulation contractor services, smart home device subscriptions, professional energy audit consulting fees, solar panel installation programs, window replacement sales. Solar control window film costs between $15 and $25 per window. You apply it yourself without professional tools in under 30 minutes per window. No licensed contractor is required. No permit is needed. No annual inspection. No service contract. The film performs its function for up to 10 years without intervention. You cannot build a $60 billion recurring revenue industry on a product that a homeowner purchases once and replaces every decade. You cannot generate contractor labor fees from it. You cannot attach a monthly subscription to a roll of film. You cannot patent the behavior of infrared radiation. What cannot produce recurring revenue will not appear in the marketing budget of any industry whose income depends on your bill remaining at its current level. That is not a conspiracy. It does not require coordination between companies or secret agreements. It requires only that no business with a profit interest in your energy bill has any incentive to show you a $15 solution. So none of them did. For 50 years, none of them did. Part 6, the documented results from real homeowners. The data from residential applications exists. It has been collected by the Department of Energy, by state energy offices in California, Arizona, Texas, and Florida, and by academic researchers in building science programs. A family in Phoenix applied solar control film to 3 south-facing and west-facing windows. Total material cost, $31. Their electricity bill dropped by $112 the following month compared to the identical month in the prior year. Full payback of their investment, under 30 days. A homeowner in Tucson with a 1,400 square foot single-story home applied film to all south and west windows. The application covered 9 windows. Total cost of $180. Their summer cooling bills dropped by an average of $95 per month over the 3 months following installation. Annual savings projection from that single intervention, over $1,100. In Florida, a study conducted by the Florida Solar Energy Center measured cooling energy reductions in residential homes that received window film treatment. Average cooling load reduction in treated homes between 25% and 40%, depending on window orientation and home configuration. In Texas, the Texas A&M Energy Systems Laboratory documented similar results in test homes across central Texas. Homes with unshaded west-facing windows and no solar control treatment showed cooling loads reduced by 30% or more following film application, with full cost recovery typically achieved within the first summer season. These are not edge cases or best-case scenarios. They are mid-range documented outcomes from peer-reviewed research and state agency reporting. Part 7. The materials, the method, and the result. Here's the complete application process. Step 1. Identify your priority windows. Walk through your home and locate every south-facing and west-facing window on every floor. South-facing windows receive high-intensity sun from late morning through early afternoon. West-facing windows receive direct intense sun from mid-afternoon through evening. These are your primary solar heat entry points. They are where the BTU load is highest and where treatment will produce the most immediate and measurable results. Note the dimensions of each window. Standard film rolls cover most residential window sizes with minimal waste. Step 2. Select the correct film. Not all window film is the same product. The specification you need is this: a solar heat gain coefficient, abbreviated SHGC, rated at 0.40 or below. This number represents the fraction of solar heat that the film allows through. A rating of 0.40 means 40% of solar heat passes through. A rating of 0.25 means 75% is blocked. Lower numbers mean more heat rejection. Select a film with at least 50% visible light transmission. This rating measures how much visible light the film allows through. A film with 50% VLT will keep your rooms naturally bright. You are blocking infrared radiation, not blocking visible light. These are different parts of the spectrum. The film separates them. Your rooms will remain lit while the heat load drops. Reliable brands currently available include Gila, BDF, and M&T. All three produce films that meet the SHGC specification needed for meaningful heat reduction. Prices range from $15 to $25 per roll for standard residential window coverage. Step 3. Apply the film mix, a solution of 50% water and 50% liquid dish soap in a spray bottle. This solution keeps the film mobile on the glass during positioning, allowing you to adjust before the adhesive sets. Clean the window surface thoroughly. Any dust or debris trapped under the film will create permanent bubbles. Spray the clean surface generously with your solution. Cut the film to the size of your window, adding approximately 1 inch on each edge for trimming after placement. Peel the adhesive backing and spray the adhesive side of the film lightly with the same solution. Place the film onto the wet glass and position it. Using a rubber squeegee, work from the center of the film outward toward each edge in smooth, firm strokes. This step pushes the solution and any air pockets out from under the film. Work systematically and do not skip areas. Trim the excess film at the edges with a straight edge and a sharp utility knife. Step 4. Allow full cure. The adhesive requires 72 hours to bond completely to the glass. During this curing period, some haziness or small remaining bubbles may be visible. This is normal and expected. After the curing period is complete, the film becomes fully optically clear and the bond is permanent. Do not evaluate the appearance of the film until after 72 hours have passed. Each window takes under 30 minutes from start to finish, including cleaning and trimming. A complete home application across all south and west facing windows can typically be completed in a single weekend. Solar control window film is not an isolated case. Thermal mass design, the principle of using dense interior materials to absorb heat during the day and release it at night, reducing cooling load without mechanical intervention, has been documented in architectural literature since the 1940s. It is rarely mentioned in energy efficiency marketing aimed at residential homeowners because it requires no purchased product and no installation service. Radiant barriers, reflective insulation installed in attic spaces that blocks radiant heat transfer from the roof into the living area below, have been tested and documented by the Department of Energy and by the Oak Ridge National Laboratory since the 1980s. They reduce attic temperatures by 20 to 30 degrees Fahrenheit in hot climates. A radiant barrier installation for a standard residential attic costs between $150 and $500 in materials for a do-it-yourself application. The HVAC industry does not lead with this option. Strategic exterior shading using overhangs, awnings, or deciduous trees on south and west exposures can reduce solar heat gain by 50% or more without any modification to the building itself. The physics have been documented since the 1950s. Landscaping for passive cooling is taught in architecture schools. It does not generate recurring revenue. Each of these interventions, like solar control window film, is a one-time action with a long, useful life and a low material cost. Each of them addresses the actual physical mechanism generating your cooling load rather than applying more energy to compensate for that load. The pattern is not accidental. It is the predictable result of a market structure where information reaches consumers primarily through channels funded by industries that benefit from higher consumption. Part 9. What you do this weekend. The solution to 50 years of this is a weekend. Walk your home today and identify every south-facing and west-facing window. These are the windows where afternoon sun enters directly. In most homes in warm climates, there are between 4 and 8 of these windows. Search for solar control window film with an SHGC rating below 0.40 and a VLT rating above 50%. This specification blocks the heat while preserving the light. It is available from multiple manufacturers and ships within standard delivery windows from major online retailers. Purchase enough film to cover your identified priority windows. For a standard home with 6 south and west windows, total material cost will typically fall between $90 and $150. Apply the film over one weekend using the process described above. No tools beyond a spray bottle, a squeegee, and a utility knife are required. No contractor, no permit, no professional. Allow 72 hours for curing. Then open your electricity bill. The Department of Energy's own documentation projects that solar control window film applied to south and west facing windows in warm climate zones will reduce cooling energy consumption by 25% to 40% in the first full billing cycle following application. In homes where cooling represents a large fraction of total electricity use, that reduction translates directly into measurable dollar savings visible on the very next bill. A $15 roll of film on a $1,000 per year cooling bill pays for itself in a matter of weeks. The film performs for up to 10 years. The math is not complicated. The knowledge was always there. It sat in government documents, in federal building specifications, in Department of Energy reports, and in the windows of every major commercial skyscraper in every major American city. It simply was not sent to you, because sending it to you was not in anyone's financial interest. Now you have it.